Let's be real. If you've ever written a line of Java, you've definitely used an array. They're kind of the bread and butter of storing data. They're simple, they're fast, and they're efficient. But that efficiency comes with a price. In this explainer, we're going to break down the key drawbacks of Java arrays, so you can understand when, maybe, just maybe, a different tool is the better choice for the job.
So arrays are powerful, right? They're fast, they let us store a bunch of values all in one place. We see them everywhere, from simple lists of numbers to really complex 3D models. But are they perfect for every situation? Well, it turns out that knowing their weaknesses is just as important as knowing their strengths.
So here's our game plan. First up, we'll do a quick recap on what makes arrays so great in the first place. Then we're going to dive deep into their two biggest limitations, that fixed size and their really strict rule about data types. After that, we'll touch on the alternative that makes these drawbacks so obvious. And finally, we'll wrap up by figuring out when an array is still the absolute best tool you can choose.
All right, Section 1. Before we start pointing fingers at the problems, let's give arrays their proper due. We have to understand why we even use them so much. It really all comes down to their structure and their raw efficiency.
You want to know the secret sauce to an array's speed? It's all about how it sits in the computer's memory. When you create an array, Java finds a single, continuous, unbroken block of memory for it. Think of it like a row of parking spots that are all connected. Since they're all in a perfect line, the computer can jump to any element almost instantly. It just needs to know its position. This incredible speed is exactly why arrays are the foundation for so many other more complex data structures.
Okay, let's get into our first major drawback. And believe me, it's a big one. We're talking about the problem of inflexibility. See, once you create an array, you are stuck with its size forever.
So here's what that really means. When you declare an array and you tell it, hey, I need space for 4 things, the system carves out exactly enough memory for those 4 elements, all side by side. And that's it. That block of memory is now set in stone. You can't ask it to grow later if you suddenly need to add a 5th element, and you can't shrink it down to save space if you only end up using 2.
And this example right here shows the problem perfectly. Let's say we make an integer array with a size of 4. No problem. We can easily put numbers in index 0, 1, 2, and 3. But the very moment we try to put something in index 4, that 5th spot that doesn't exist, bam! The whole program crashes with an array out of bounds exception. That's just Java's way of screaming, stop, you're trying to park in a spot that isn't there. Now, you're probably thinking, okay, but what if I really need more space? Well, the only solution is kind of clunky. You have to literally create a brand new, bigger array. Then you have to go back to the old array and manually copy every single element one by one over to the new one. I mean, it works, but it's slow and it takes up processing power. It's really not ideal.
Okay, on to our second big limitation. This one is all about what you can and, more importantly, what you can't put inside an array. It's what we call the rule of homogeneity.
Homogeneous is just a fancy word that means all of the same kind. The best analogy is an egg carton, right? It's designed to hold eggs, and only eggs. A Java array is the exact same way. When you create it, you have to declare its type. If you say it's an integer array, you can only put integers in it. If it's a string array, guess what? Only strings. There is absolutely no mixing and matching allowed.
This table here makes it crystal clear. If you make an integer array, filling it with numbers like 10, 20, and 30 is totally fine. But the second you try to sneak a string like hello or a decimal number like 30.5 into that same array, nope, Java will throw an error. That rule is absolute.
And this quote really just hits the nail on the head. If what you need to do is store an integer, then a string, then a double, all in the same collection, a standard Java array is simply not the tool for you. You just can't do it.
So why are we calling these things drawbacks instead of just, features? It's a fair question. And the reason is because Java actually gives us a more flexible alternative. Let's take a quick peek at what that looks like.
Let's just imagine for a second, what would the ideal data structure be? With an array, we have a fixed size and one single data type. But what if we had something that could grow or shrink whenever we needed it to? What if we wanted to store different types of data all together in one place? Well, the answer to those what-ifs is the Java Collections Framework. It's a whole library of other data structures that were specifically designed to be more flexible. For example, there's something called an ArrayList that can just grow dynamically every time you add a new item. We're not going to do a deep dive into collections today, But just knowing these powerful, flexible options exist is why we can call an array's limitations a drawback.
So with all this talk about collections, does that mean we should just stop using arrays altogether? Are they obsolete? No way, absolutely not. The most important thing to remember is that they are different tools for different jobs.
So when should you still reach for an array? Well, first, when its fixed size drawback is actually a good thing, like when you know you'll have exactly 10 items, and that number is never, ever going to change. And second, and this is a big one, when you need pure, raw performance. That simple continuous memory block we talked about makes arrays unbelievably fast. If the size is fixed and speed is your #1 priority, an array is almost always your best.
So the key takeaway here is pretty simple. Picking a data structure is always about trade-offs. Arrays give you maximum speed, but you sacrifice flexibility. Collections give you all the flexibility in the world, but they come with a tiny bit of performance overhead to manage all that. So the next time you're coding and you need to store a bunch of things, you'll face this choice. Do I need raw speed, or do I need flexibility? Now, you know how to make that decision.